Thanks everyone for joining. In this video, we will discuss one more Docker image optimization concept, which is called minimize the number of layers or explore the layers. So far, we discussed how to use minimal base image to optimize the Docker image, or how to use multi-stage build to optimize the Docker image we have seen. But in this video, how we are going to minimize the number of layers, or how we are going to explore the layers, and then how we can optimize the Docker image. Let's see. So typically in the Docker file, we will define that multiple instructions. Then using Docker file, we can create the Docker image. Then finally create the container by using the Docker image, and we can run our application. So that is where if we can take any Docker image, it consists of multiple layers. Okay, but what you have to know is when you are trying to build the Docker image from the Docker file, for that inside your Docker file, if you try to use some instructions like from work directory, copy, add, run, cmd, every time you invoke these instructions, so that for every instruction, a new layer will be created. So if you try to use any instruction 4 times separately, there will be 4 layers will be created. Example, if you want to install multiple packages, for that if you use run instruction, run apt-get install git, run apt-get install vam, run apt-get install maven, run apt-get install java. So if you used 4 times run instruction separately, there will be 4 layers will be created. Or if you want to copy or download the files from remote URLs, for that, if you use copy or add instruction several times inside your Docker file, so that many layers will be created. Now, what will happen for each instruction, separate layer will be created. So this is where for every layer that we creating, there will be the size of the image also getting increased. Okay. So what we have to do is we need to reduce the number of layers consolidating these instructions or commands which we use for the Docker file. So typically when we try to use copy or add instruction, instead of using multiple times, try to consolidate and use it one time. That means at the same time, when you are trying to execute some Linux commands inside your Docker image or Docker file, instead of using several run instructions, consolidate those several run instructions and put together as a one run instruction, so that the number of layers will be reduced and the image size also will be less. That means the image will be optimized. Now, to understand this better, let's take a couple of examples and see how we are going to minimize the layers. Example, if you can see here I have used from instruction 20.0 for this is the base image. And here I have used 5 run instruction for installing the packages. Okay, so this is the first example. In this example, I am trying to do apt update, then installing the multiple packages or software with the several run instruction. So here from is the one instruction, run 3, 4, 5, 6. 6 layers will be created because from we used one time and run we used 5 times separately. But when we are trying to create the Docker image from this Docker file, okay, whatever we are defining, typically it is going to create the image with the multiple layers, and obviously will be take more time to build each layer from the instruction, and after that the image size also will be increased. So to reduce this, here see I have used the same from instruction 20.04, and after that I have used the run instructions. All these, commands I am going to execute in the single run instruction. Ampersand is that it is one of the shell operator which we can use to combine that multiple commands. So let's see how we are going to execute them. So here I have written 4 Docker files. One is for, if you can see that Docker file 1. So as for this, I have taken, this is the base image, then I have updated, and after that I have installed a couple of packages actually. So here Git I have installed, time zone I have installed, Maven and zip VM. This is the files, softwares I am going to install. So here what we have to do. So I'm going to execute, even if you want to know the time also we can execute it. But before that Docker build, so before that Docker images, if you can enter, see nothing will be there. Docker build and -t, then you can use test colon image 1. Okay, then after that -f Docker file 1. Then you should have current directory, enter. So now it is going to download that package first. That means Ubuntu base image, which we have defined in the from instruction. Then after that is going to updating the apt update. Then after that, it's going to install that TG time zone data. Then after that, it will installing the Git, then VAM, and finally, it is going to install all the packages which we define in the instruction. So once it is installed, sometimes what we have to know is we need to capture the time also. Let's see how to capture the time. After once the image is created, we need to check what are the layers are available. So what command we need to use, how to see the layers inside of the Docker image. Let's see all of those. Sorry. Now Java is going to install. So after that it is done actually. See now zip file is going to install it. Now VAM. So all the packages which we define in that run instruction separately, so that many layers will be created. See here the image got created. So use that Docker image. So see here, this is the base image. Then after that, this is the image we have created. So now this is 557 MB actually. Okay, now how do you know what are the layers are available? So for this, we can use Docker history. Okay. And after that, image 1 colon the tag number. Sorry, test is the image. And image 1 is the tag number. If we can enter this, see here, there are around 12 layers are there actually. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Around 10 layers are there. Okay. So when we are using that multiple run instruction, so multiple 12 layers will be created. So now what we have to do. So that is where if you look at the Docker file 2, which is being optimized. So let's say Docker file 2. So instead of using multiple run instructions separately, I have used run, the first command, then ampersand. This is a shell operator which we can use to combine that multiple commands. This is the next command which we can use to time zone. Then again we can use for the ampersand. Then again we have given for that Git installation, then Maven, then zip, then finally we have used VM. Okay, let's see how it will be, whether the layers will be minimized or not. So in the same command, if we can use 2, so here I can use 2 test 2. But sometime if you want to capture the time also, before this we can use time. If we can enter, this will be captured that time, how much time it is taking to build all these layers. Okay, now the same process. So here I have consolidated all the run instructions using one run instruction, where I have combined all the Linux commands which I have used ampersand. So what will happen now? I am using the same base image and same Linux commands which were used for Dockerfile 1, but I am going to create only one layer. So ideally, the total time taken to the build all these layers will be less. Hence, the size of the image is also optimized. For this, we can use some more example, but may not see that huge difference, but see the little bit difference. But if we can go to that complex things into our real-time project, we can able to see the more differences actually. So let's see how much differences we can see between that image 1 and image 2. Okay, but this is a small example, right? You cannot see major difference actually. If we can take complex requirement, if we can segregate that Docker file, then you can see that huge difference. Okay, now see here it's showing around 2 minutes. Okay, so like this we need to get that time also. Let's see how it will go. So after that we can use Docker images. Now see test 2. See if we can compare. Earlier the image 1 will be 557 MB. Here it will be 550. There is some difference. Sometimes in KB there is a KB difference will be there. Here also sometimes we can see 557, here also 557. But if you can see that inside KB also there is a difference. But here, as for this first Docker file and second Docker file is optimized because it has that less layers compared to the first Docker file or first image. So that is where we see the difference 7 MB. Okay, this is 550, this is 557, so 7 MB is different. Now see Docker history, and I can use test2 colon image 2. Let's see the here around 5 or 7 layers. If we can use image 1, this has that multiple layers. See here, these are around 10 layers, these are around 7 layers. So there is a layers are optimized. So that means layers are reduced, image is optimized. Okay, so that is where. So if you want to minimize the number of layers, the very first thing you need to do is consolidate the instructions and use all the instruction as a single instruction. That means one instruction, so that number of layers will be reduced and obviously the size of the image also less. Okay, let's take another example. So let's look at that Dockerfile 3. Here I used that from instruction Ubuntu only same, but here I can use echo command. Just I am creating that release 1, release 2, release 3, release 4, release 5. But here we can't see more difference, but I am giving that example. So there can be, we can define that some other syntax also. Let's see how it will work. And you can see Dockerfile 4. Earlier we haven't used this escape, but here see sometimes we can see the Docker file like this also. So this is also same as for that catch Dockerfile 3. Sorry, Dockerfile. And if we can define like this also is same, or sometimes the people will be defined that Dockerfile like this only. So you can use ampersand and they can use that escape character, which is called backward slash. So same thing, second one and third one, it will be continuing. Fourth one, they cannot keep this backward slash because there is no fifth actually. That means there is no fifth file is created. Okay, so that is where what we need to do is, here we used that multiple run instructions, and here we used only one run instruction. Let's see how it will be executed. So we can use that. If you want to capture the time, you can capture it, where we can use the Docker file 3, and here I can use for the image 3, and here I can use for the test 3. So now see, so even time also it's taking less time, so around 1 minute actually. Okay, then after that Docker images, and he 72.8 MB, and you can use that same thing actually. What is the Docker history command is the right image 3, and here you can use test 3. Here there are multiple layers, around 10 layers got created again. Then if you can use that, so same thing, instead of Docker file 3, Docker file 4. Now see, look at this time also, you can look at this 6:41 second like that. But if you can go here, see here, not this one, image 3. See here, if this is image 2, so here we can see the time actually. That's what I'm scrolling down. Now here the time is, it's taking less time compared to here. See 3:7:82, but here if you can go, see here only 6:41 seconds. Okay, so if we can take that optimized Docker file, it's taking the less time to build all the layers actually. So if we, even if we can go to the Docker images, and here the size is same actually, because this is very less Docker file. It's a small example, so that's what, even if you cannot see the difference. So if you want to see the difference, you can use that Docker history. Then after that, test4 colon image 4. So if you can enter, see here less layers, and say at the same time, if you can use 3 and 3, see here, these are the more layers, these are the less layers. Okay, so this is how here I can just execute everything in one run instruction together, and I can use ampersand. This is shell operator which will help you to combine multiple shell commands. So this is how we are going to minimize the layers to optimize the Docker image. So please go through it. If any doubts or any issues, or if you cannot understand, can you please comment in my channel. So I will do one more video for one more optimization concept. So I can share that once all these optimization concepts are done, I will share that multiple examples in separate video. So we will see it actually. So thanks for watching. If any doubts, could you please post your comment in my channel.